Welcome, travelers, to Adventures in Security. In this video, we explore how to discover vulnerabilities and how to manage the weaknesses we discover. You can download the video script from the link below. Today, we're going to demystify vulnerability scanning and, more importantly, learn how to use it without drowning in alerts. Vulnerability scanning is the practice of checking systems, applications, and configurations for known weaknesses. It's not magic, and it's not a replacement for secure design, patching, or penetration testing. Think of it like a smoke detector. It doesn't prevent fires, but it gives you early warning so you can act fast. By the end, you'll understand why scanning matters, how to prepare so results are accurate, how to run scans safely in production and before go live, and how to prioritize findings using CVSS severity and EPSS likelihood, so your team fixes what actually reduces risk. Let's define the tool we're talking about. Vulnerability scanners compare what they observe, software versions, open ports, headers, configurations, against databases of known vulnerabilities and misconfigurations. Many scanners can authenticate into hosts or cloud accounts, which dramatically improves accuracy because they can see installed packages and settings rather than guessing from the network. The output isn't just a scary list. Good results include evidence, affected assets, a vulnerability identifier, like a CVE, and a remediation suggestion. Remember the boundary. Scanners are great at known knowns, but they won't reliably find custom logic flaws, broken authorization, or business process issues. That's why scanning complements code review, threat modeling, and penetration testing. Why invest in scanning when everyone's already busy? Because most real-world incidents involve known issues, unpatched software, exposed management ports, weak configurations, or overlooked dependencies. Scanning helps you continuously reduce the attack surface and catch configuration drift, where systems slowly become less secure over time. It also supports compliance by providing evidence that you're monitoring and addressing vulnerabilities. But the big win is operational. Scanning turns security into a measurable process. Instead of vague statements like, "We're secure," you can track coverage, time to remediate, and risk trends. The key is not running scans once a year. The key is building a routine that finds issues early, routes them to the right owners, and verifies fixes. Vulnerability scanning actually covers several categories. Network and host scanners look at systems, such as open services, OS packages, and configuration. Web application scanners, often called DAST, probe websites for issues like outdated components or common web vulnerabilities, useful, but not perfect for custom logic. SCA tools scan code dependencies for vulnerable libraries, and container/image scanners check base images and packages. CSPM-style scans focus on cloud misconfigurations like public storage, overly broad IAM, or insecure network rules. One huge decision is authenticated versus unauthenticated scanning. If you can safely scan with credentials, you'll usually get fewer false positives and better detail. Unauthenticated scans are still useful for identifying what an attacker could see from the outside. Most scanning failures are preparation failures. Start with an asset inventory. You can't scan what you don't know exists, and findings need a clear owner. Next, plan safety controls. Scan windows, throttling, and exclusions so you don't overload fragile services. For authenticated scans, treat credentials like production secrets, use vaulting, least privilege, and rotation. Define scope clearly. Are you scanning production, staging, endpoints, cloud accounts, and third-party services? Also decide perspective. External scans reflect attacker view. Internal scans reflect lateral movement risk. Finally, create baselines. Some findings are intentional, like a legacy protocol required by an old vendor. Document these as exceptions with compensating controls. Otherwise, your team will waste time fighting the scanner instead of reducing real risk. Does scanning work? Yes, when you use it for the right job and pair it with a process, it's excellent at detecting known CVEs, missing patches, and common misconfigurations. But scanners can be wrong in both directions. False positives happen when a version looks vulnerable but isn't exploitable due to backported fixes or mitigations. False negatives happen when the scanner can't see the right data, lacks credentials, or the environment differs from assumptions. The way to judge success isn't how many vulnerabilities did we find, because more findings can mean worse hygiene or broader coverage. Instead, measure coverage of critical assets, time to triage, time to remediate, and verified closure, meaning a rescan confirms the issue is actually gone. Production scanning is absolutely possible, but treat it like any other operational activity. Begin with your highest value assets, such as internet-facing systems, identity services, and systems handling sensitive data. Use low-impact scan profiles and throttle aggressively, especially on legacy or resource-constrained services. Authenticated scans often reduce noisy network probing and improve accuracy, but they require careful credential management. Align scans with change windows and have an escalation plan if scanning triggers alerts or performance issues. Most importantly, make scanning continuous, not occasional. Schedule scans regularly and always rescan after patch cycles to verify closure. A good production workflow is detect to triage, to ticket to fix to verify. When verification is part of the routine, scanning becomes a reliable control instead of a monthly panic. The easiest vulnerabilities to fix are the ones you catch before production. For new systems, add scanning into the pipeline and staging environments. Dependency scanning during builds, container image scanning before deployment, and dynamic scanning against a deployed staging instance. Use release gates carefully. Don't block on every medium issue, or you'll teach teams to bypass the tool. Instead, block on agreed thresholds, like critical vulnerabilities or high-risk exposures. Also focus on golden paths. Harden base images, secure defaults, and infrastructure as code modules that bake in good configuration. When the baseline is strong, scanning becomes a confirmation step rather than a list of surprises. This is the shift-left mindset. Fix earlier, reduce rework, and prevent risky patterns from ever reaching production. When results come in, don't start by sorting by severity alone. Start by validating. Is the finding real? Is the vulnerable component actually present? And is it reachable in your environment? Next, add context. A high-severity issue on a lab box is not the same as a medium-severity issue on an internet-facing payment system. Consider exposure, public versus internal, plus compensating controls like WAF rules, network segmentation, or configuration hardening. Deduplicate aggressively. Many scanners report the same underlying problem across hosts, containers, and images. Grouping by root cause, like outdated OpenSSL package in base image, lets you fix once and eliminate dozens of alerts. Finally, create actionable tasks. Exact patch version, config change, owner, and verification method. CVSS is the most common way scanners express severity. It outputs a score from 0 to 10 based on standardized metrics. When you use a CVSS calculator, you're essentially answering structured questions. Can it be exploited over the network or only locally? Does it require authentication? Is user interaction needed? How big is the impact to confidentiality, integrity, and availability? That's the base score. But here's the key classroom point. CVSS is not your business risk by itself. Your environment matters. Environmental scoring lets you adjust based on factors like how important the affected system is and whether certain impacts are actually relevant. In practice, teams often use CVSS as a severity baseline, Then combine it with exploit likelihood and asset criticality to prioritize work. If CVSS tells you how bad, EPSS helps answer how likely. EPSS, exploit prediction. Scoring system produces a probability estimate that a vulnerability will be exploited in the wild based on observed signals and characteristics. This is powerful because two vulnerabilities with similar CVSS scores can have very different real-world urgency. A high EPSS score often means attackers are actively targeting it, or it has traits that make exploitation common. The best practice is to combine CVSS for potential impact, EPSS for likelihood, and your local context, exposure, controls, and business criticality. Also pay attention to threat intel indicators like known exploited lists or active exploitation advisories. EPSS doesn't replace judgment, but it makes prioritization far more evidence-driven. For a more detailed view on how to use the EPSS, please watch my video at the link below. Let's turn this into a repeatable method. A simple model is priority equals severity times likelihood times context. Severity can come from CVSS. Likelihood can come from EPSS plus any known exploited signals. Context includes exposure, public-facing or internal, plus asset criticality. Does this system impact revenue, safety, customer trust, or regulated data? From there, define service-level targets. For example, internet-facing critical assets with high CVSS and high EPSS get addressed immediately. Internal low criticality systems with low EPSS go into a normal patch cycle. If a team requests an exception, require documentation, why it can't be fixed, what compensating controls exist, and when it will be revisited. And always measure outcomes, triage time, fix time, and verified closure. To wrap up, the difference between we have a scanner and we manage vulnerabilities is operational discipline. Assign ownership by domain, endpoints, cloud, infrastructure, and applications. Automate routing into ticketing with good metadata. Asset owner evidence and recommended fix. Reduce noise by tuning scan profiles, using authenticated scans where safe, and maintaining exception lists with expiration dates. Establish a regular cadence, weekly for critical internet-facing assets, maybe monthly for lower-risk areas, and always scan after major changes like new deployments, network rule changes, or base image updates. Finally, invest in training. Teach engineers what the findings mean and how to fix root causes. When scanning is predictable, low noise, and tied to verification, it becomes a trusted part of engineering, not a surprise attack from security. That's it for this video. If you learned anything, please remember to give us a thumbs up and subscribe. And until next time, be careful what you click.